Hello friends, this video on aldehyde ketones carboxylic acid part 27 is brought to you by examfear.com. No more fear from exam. Let's see this preparation method of carboxylic acid from acyl halide. See, with this acyl halide or acid chloride, you have RCOCl. This is my acyl halide of this form. When you hydrolyze with water, you get carboxylic acid. Actually, OH group replaces Cl group because Cl is a good leaving group, right? So the reaction mechanism is, if you see, right, this carbon, it gets slightly negative, this gets slightly positive. Also, chlorine attracts electron towards itself, so it gets all the more positive. This carbon is very, very reactive, right? Carbon has a huge positive charge. So what happens is, I'll show you the reaction mechanism. Cl, you have this water. Water has lone pair of electrons, right? So now this is attracted towards this. With this bond breaks, and what you get is RCO minus Cl, and oxygen gets a positive charge because oxygen has given electron to carbon. Correct? Now in this case, what happens is this oxygen has a negative charge. It wants to be stable, so it has lone pair of electrons too, so it passes the electrons here and this bond breaks. This becomes RCO OH and positive charge on oxygen. Plus Cl minus comes out. Again, there's a positive charge on oxygen, which is not happy because oxygen is the electronegative element, so it asks hydrogen to leave. This hydrogen leaves as H plus, so this becomes RCOH, and H plus and Cl combines to form HCl. So that is how it occurs. This is the reaction mechanism. Pretty simple. So you have water reacting. This carbon is very reactive actually because chlorine attracts electron from carbon, it makes positive. Also oxygen attracts electron from carbon, this is positive. So it's all the more positive because it is bonded by two highly electronegative element. And with this, a nucleophile water can easily attack and the reaction happens. The next is we'll try to prepare carboxylic acid by anhydride. Here also we'll do the same thing, we'll hydrolyze. So we'll have anhydride. Similar reaction we'll do a hydrolysis and we'll get carboxylic acid. I'll show you an example. For example, I'll write you the general mechanism. This is, let's suppose, an anhydride. Here also, if you see, this is slightly negative, slightly positive, so it can easily be attacked with water. So this will attack here. So with this, what you get is RCO minus O. This is what you get, and this oxygen will get a positive charge because it has given electron to carbon. Now this carbon wants to get rid of this negative charge. It has a lone pair of electron too. It will move in this fashion and this bond will break. So with this, what you will get is RCO O minus, RCO, this bond will break actually. You will get O H with the positive charge, and this one you will get, let's suppose this is R dash, you will get R dash COO. You will get a negative charge in this. Now here, if you see, this oxygen want to get rid of this hydrogen, a positive charge, because oxygen is an electronegative element, it doesn't want positive charge, and this guy want a H plus. So this bond will break and this H plus will go to this oxygen. Oxygen will attack on this H plus. So what this, you get RCOOH and R dash COOH. This is what you will get. Correct? For example, if let me take an example. So if I have phenol here and this compound, this is called, I don't know, this is a compound. If you do hydrolysis, you will get benzoic acid, 2-benzoic acid actually. right? Maybe this is benzoic anhydride, I don't know. So this is, or you can, if suppose I have this compound, this is benzoic ethanoic anhydride actually. Here also if you do hydrolysis, what you get is this one plus CH3 COOH. This is what you get, correct? This is my benzoic acid, this is my ethanoic acid. The next is we'll prepare from ester. Here also we'll do the same thing. We have ester, we'll do hydrolysis. And again we'll get carboxylic acid. Same thing, for example, let's suppose we have RCOOOR dash. This is my ester. Again, if we react with water, this is anyway acidic, and this has negative charge, this has slightly positive charge. In fact, this is not that reactive, so we'll do generally with acid. So we'll have H plus first coming into picture, attacking this guy, and this by coming here. So with this you get RCO minus OR dash OHH with a positive charge. This is what you get. Again, what happens is this guy has a lone pair, so it goes in this direction, this bond breaks. You get RCOO OH and H with a positive charge, and this R dash O is pending with a minus charge. So this oxygen again wants to get rid of electron. So this hydrogen, oxygen want to get rid of this positive charge because it's a electronegative element. This hydrogen goes off and this oxygen attacks this hydrogen. So what you get is RCOOH and R dash OH. This is the typical reaction mechanism. You can take some examples. For example, I have this compound, this is the ester, RCOR form, and you do hydrolysis. What you get is COOH and this part C2H5 OH. This is what you get. Or let's suppose you have this compound, correct? This compound, you do hydrolysis, what you get is 1, 2, 3 carbon, COH and COH. This is what you get. This is how it breaks from here. Or it breaks from here actually. It breaks from here. This is what you get. The next is oxidation of hydrocarbons. So we can also prepare carboxylic acid by oxidation of hydrocarbon at a very high temperature. So you take a very long chain aliphatic hydrocarbon and then you use catalyst Magnus, steer it also at a very high temperature, 400 Kelvin, and you need oxygen, you'll get carboxylic acid. There is no reaction mechanism for this, but it is something like this. You have this long chain aliphatic hydrocarbon, right, to react with the presence of oxygen and use Magnus stearate as a catalyst at a very high temperature, maybe 400 K. What you get is carboxylic acid. So an example, if you want, I can give you, for example, CH3, CH2. It can be in a very big long chain carboxylic acid, oxygen, 400 Kelvin. I have my catalyst, manganese stearate, and what I get is N and I get COH. This is how you get this. So the terminal alkyl here becomes carboxylic acid. This is what happens. It's oxidation reaction actually. We have seen, right? We have told from alkanes to alcohols and aldehydes and carboxylic acids, from alkanes to directly. This is alkane. Just write once again. Alkanes to alcohol to aldehydes to carboxylic acid. This is how it happens if you keep doing on oxidation. This is the oxidation directly from alkanes to carboxylic acid. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.